In this video, we'll be applying the method of solving matrices to this particular systems of equations. This particular systems of equations, again, we should have this nice little squirrely bracket on the side. I'm going to transform it first to a matrix. We have to be very careful with transforming this thing to a matrix because, again, we don't want to confuse anything. Remember, your first column is always your x's, your second column is generally your y's, your third column is your z's. You generally have an augmentation attached to this, and then you have your constant solution values. What I'm going to do is I'm going to leave this augmentation part out because I'm going to get lazy in terms of drawing these, but I am going to go ahead and fill in all the values. I have a 2 for my x here. I have a -1 for the y. Make sure that you include the negatives with that. I have 0 z's in that, and then I have a 10 for the last value. The next one here, I have +1 for x, 0 for y, -1 for z, -1 for my constant, and then 0, 1, 1, -9. Now, the next few steps is, again, the operations mixed with the goal. Our first goal, remember, is to aim towards getting 1, 0, 0, 0, 1, 0, 0, 0, 1, aiming for this piece first, then the zeros below it, this piece second, the zeros below it, and this piece third. If I can aim for that right there, I can get my A, B, and C as logical values to the solution of this system. Now, the other piece that we have to remember is the operations we're allowed to do. Number 1, we're allowed to swap 2 rows. Number 2, we're allowed to multiply a row by any number we choose. And number 3, as long as it's not 0. I didn't specify that before. We can't multiply a row by 0. It's just going to turn everything into zeros, and it's not going to make any sense. Again, the idea is, are you allowed to multiply this side by 0 and this side by 0? Well, yeah, but it doesn't help you solving the system. And so the third equation that we have is multiplying a row by a number temporarily, adding it to another row, and storing it back in that other row. So for this one right here, again, I'm going to focus on just this first column. My goal is to get a 1 here, and using those or thinking about those 3 operations, the first operation that I see that's the most efficient is simply taking row 2 and swapping it with row 1. It's going to put that 1 right there, it's going to put that 2 right there, and I'm going to have a 1 in the corner piece where I want it, and then I can work towards getting the zeros below it. This is not the only operation that could work. I could, for instance, take row number 2, I could multiply row number 2 by a -1, making this a negative, and then adding it to this row. That'll change that to a 1, and this will still be a +1. Again, it doesn't matter which way you choose to do this set of operations. What matters is that you aim towards, again, 1, 0, 0, 1, 0, and then 1 in that order. So the operation I'm going to choose to do is the first operation that I decided that I thought about doing was row 1 swapping with row 2. Doing the swap operation will make things very smooth in terms of solving for the values I'm looking for. One thing to note when changing these values, please make absolutely certain you double and triple check your setups. It would be very unfortunate to do this the entire problem correctly, but your first matrix has a wrong value in it. That, again, would be just a god-awful terrible. So when you're solving these things here, again, I'm going to check 1, 0, -1, -1. Yes, that's correct. And 2, -1, 0, 10. Yes, that's correct. Okay, so I've swapped row 1 and row 2. This provides me with a 1 in that first location, that upper corner quadrant. And I'm going to go ahead and figure out a way to take this 1 and use it to make this value a 0. This is already a 0, so I don't need to modify it. Now, again, notice how all the things that I'm pointing at and I'm working with are all in this first column, because the first column was what I'm playing with. I'm going to have to, anytime I do an operation, I'm going to have to play with the rest of the row, but I really only care about 1, 0, 0. Again, 1, 0, 0. So if I want to get a 0 here, I have to take my second operation and change it to being row number 1 multiplied by a -2 added to row number 2, and store that back in row number 2. Now, again, I don't often show the operations off to the side, but I'm going to continue doing that for this video just to make sure that it's emphasis on what's going on. So I'm taking row number 1, I'm multiplying it by a -2. That means I'm going to have -2. My 0 changes to a 0. My -1 changes to a +2, and my -1 changes to a +2. So that is row number 1 multiplied by -2. Row number 2, unchanged, is going to be 2, -1, 0, and 10, and I'm simply going to add those two values together. This is going to give me 0, -1, 2, and 12. So in my new matrix down here, again, remember, row number 1 we didn't touch. Row number 1 we didn't permanently touch. Row number 3 we didn't touch at all, and row number 2 is what the new conclusionary row that I have. So 0, -1, 2, and 12. So now I've got my 1, and my 2 zeros. Again, the first 2 steps of my solving a matrix is done. My next step is try to get a 1 in this middle location. Now, once I have finished getting 1, 0, 0, you no longer want to look at that column. You're done with dealing with that column. Yes, you still might have to do algebraic manipulations with it, but we shouldn't be touching that column because we shouldn't be using row number 1 for any of the math that we do. If we use anything for row number 1, we're going to end up multiplying row number 1 by a number and adding it to this row or this row. Notice that'll change those zeros. And the order that you get these things in must be constant. So I get the 1 here, then the zeros below it. Then I can't change any of that column. So it means I can't use this row because it will change that column. So I'm really focusing on these two numbers here in such a way to get a 1 here or a 0 here. Again, the 1 isn't necessary, but it's really helpful. So looking at this setup right here, it looks like there's a couple of easy ways I can get a 1. Number 1, I could swap these 2 rows again. It's important to note when swapping rows that if you use a computer or a calculator to solve these matrices to check your answers, there's a couple of intermediate steps that'll try and check your answers for. It doesn't generally do that row swapping operation. So you might get an intermediate step that's drastically different than the calculator gets, specifically because it doesn't use the same operations. It forces these 3 rows to be stagnant and stationary, and they don't change them. But we can change them. So that's our first choice of possible operations we could do, is taking this multiplying or swapping these 2. The next thing I could do is I could just take this row number 2 and multiply it by a -1. That'll put a 1 here, a -2, a positive or a -12, and I will get a positive 1 here. Now, again, the goal is to try and solve these. We're going to have to show all the steps that we do, and yes, that means that it is necessary that we show operation 1, operation 2, and then operation 3. It's important to know what steps you're taking, so if you make a mistake somewhere, we can potentially find it. So this is the last step that I'm going to attempt to do effectively. Now there's technically 2 or 3 more steps you could do. I'm going to try and do this in the smoothest way possible. So what I'm going to do is I'm going to bypass getting this 1 here. Again, I don't need that 1 there, it just generally helps. What I'm going to do instead is I'm simply going to take row 2 and I'm going to add it to row 3. Again, the reason why I'm going to do this, adding it to row 3, I'm going to store that back in row 3, is because if I take this -1 and I add it to this positive 1, I'm going to get a 0 here, and therefore I have z equals to something. So very carefully, let me go ahead and do that, and I'm not going to show the extra scrap work over here. I'm just going to rewrite this 0, 1, -1, -1. Again, I'm not permanently changing row 2 in any way, so I'm just going to rewrite that. And then row 3 is going to be me taking 0 added to 0 is 0. -1 added to 1 is 0. That's what I wanted to happen. 2 added to 1 is 3. That's unfortunate, but it'll be fine. 12 plus 9 is 3, and that's why it's going to be fine. Because now, this bottom equation says 3z equals to 3, and therefore z equals to 1. I now have a solution for the z value. I need to go ahead and now work my way backwards to get what y and x are. Now it is generally common for when we solve these matrices for them to turn up this way, to be z being found first, then y, then x. It almost happens consistently just because of the way that we process on how to solve these. So now the next equation is actually -1y plus 2z equals to 12. And again, remember this 4th column is the equals. Technically, I should have had augmentation all the way down that. I just got lazy and decided not to write it. Again, it's not necessary. It just helps to keep track of what's where. So now, after I've gotten that, I know that -1y plus 2 times 1 equals to 12. I'll subtract the 2, getting 10. I'll divide by a -1. Therefore, y is equal to a -10. So now I've got my z and my y. I'm going to go ahead and back up here to find my x. You'll notice in this case I didn't actually need to solve for y to get my x, but I do need to solve for y for the final solution. So I have 1x minus 1z equals to a negative 1. If I plug my z value in, I'm going to go ahead and draw that over here. X minus 1 equals to negative 1. If I add the 1 to both sides, I'm going to get 0, and therefore x is equal to 0. This is a valid solution. Please don't be afraid of getting zeros in your x, y, and z terms and locations. In this case, I have 0, negative 10, comma 1 as my solution to this system. And it's also important to understand what the solution to this system is. These three equations are equations of three unknowns. Equations of three unknowns are generally planes in a four-dimensional space. Think of the walls in your room. You have hopefully a ceiling and then two side walls at the very least. That will then create a corner in the center. You'll notice that that corner in the center is the convergence of all three of those planes, both the ceiling and the two sides of the walls. That location right there would be this solutionary point in the concept. So again, thinking this way here, we have the ceiling and the two walls touching. This is one plane here coming in, that's one wall. This is the other plane coming here, that's the second wall. And then you have this ceiling on top, that's the third wall. Right there is where all three of those intersect. Now it is possible to have other more complicated solutions, and we will go over more of those complicated solutions in other videos. But for this, it's really important to understand that the solution to three different planes intersecting in a four-dimensional space is generally a single point. And that right there is the single point to the solution of this system, utilizing those appropriate operation methods.